Hey everyone, my name is Sandip and today I will be solving Leetcode problem 3196, maximize total cost of alternating subarrays from the weekly contest 403. In this problem, we are given an integer array nums with length n. So we are given an array nums of length n. Our task is to split the array nums into subarrays such that the total cost of the subarrays is maximized. So basically, we are given an array and we need to split it into subarrays such that when we compute the cost of each of those subarrays, the total cost is maximized. Now, how do we define the cost of a subarray? So the cost of a subarray, nums of L to R, where L and R lies between 0 to n, is defined as this. So the cost of L comma nothing but nums of L minus nums of L plus 1 plus nums of L plus 2 minus nums of L plus 3 and so on. So basically, we include each element and we keep alternating the signs. As you see, the signs are kept alternating, minus, plus, then again minus, again plus, and so on. So finally, we need to return an integer denoting the total cost of the subarrays after splitting the array optimally. So these are the two sample inputs given in the problem statement. Let's see how do we solve them. So first input is given as 1, minus 2, 3, 4. So let's split it into something like this. So we can split into 1, minus 2, and the next subarray is just 3 and the next subarray is 4. So we do two splits, a split here and a split here. So these are the possible subarrays. Now what is the cost of this subarray? It's nothing but 1 minus 2, which is basically 3. The cost of this subarray is 3 itself and the cost of this subarray is 4 itself. So total cost is 4 plus 3, 7 plus 3 is 10. So the total cost is 10, which is the answer for this particular input. So for this sample input, we can split it from here. So what do we get? We get 1, minus 1 as one subarray, another subarray is 1, minus 1 again. So the cost of this one is 1 minus 1 plus 1 minus 1. So the cost of this is 2 plus 2, which is nothing but 4. So the answer for this array is also 4. So pause the video here if you want to think of a solution by yourself, else let's proceed. So the problem can be solved using dynamic programming. Let's see the reason why. So for any problem to be solved using dynamic programming, it has to support these two features. First is overlapping subproblems and optimal substructure. So let's see for this particular example that we are solving. So this is the array that we are given. In this array, let's try to do one split first. So we can split it from this index, this or this. So what are the possible outcomes? So let's draw a tree diagram. So it will have either we split it here, so we get something like this, or we can split from here, which means after the first split it will be like this. And what else? We can also split it from here, which means we can have something like 1 minus 2, 3, and the final is this. So if we apply only one split, this is what we get. These are the possible subarrays. Now let's say we perform the second split. What do we get? Either we do a split here or here. So what are the possible outcomes? So we get 1 minus 2, 3, 4, or we get 1 minus 2, 3 and 4. So we do the split here. Okay, let's do on this one. Again, two possibilities. So we either get 1 minus 2, 3 and 4, and let's say we do a split here in this entire thing. So we get 1 minus 2, 3 and 4. Same for this. Let's try to split it. So we either split it here or here. So we get 1 minus 2 and 3 and we get 4 always, or we split it from this one, right, and this entire thing. So we get minus 2, 3 and 4. So let's see if there are overlapping subproblems. Definitely this particular thing and this particular thing is same. So these two subproblems overlap. Similarly, if you see, even this one and this one overlap, which means we have overlapping subproblems. And if we know the answer to smaller subproblems, we can just combine them to get the solution of the bigger problem. So that means we have both overlapping subproblems and optimal substructure. So now we know that these two properties exist. We can definitely apply dynamic programming. Let's see how. Okay, so as seen from the previous tree diagram, At every point we were thinking whether we do a split or not. So let's see. So what I am doing is I have taken a DP state which says me what is the maximum sum if we split at index I and what is the maximum sum if we don't split at index I. So every time I am keeping two states. If I do a split, what is the maximum sum? If I don't do a split, what is the maximum that I can make here? Okay. So let's see the base cases. This is exactly what was my thought process during the contest also, the way I solved the problem. So let's fill these values quickly. So the base case is, let's see if I just have one single element in the array, what will be the values of these ones? If I do a split, nothing matters, it will just be 1 because I have nothing before that. So there is nothing and we just get 1. So that means we just have the value 1 here. If we do not do a split, if we do not perform any splits at index I, what do we get? There was nothing before, so again we just have the same element as it is. So that means the base case can be the same value nums of 0 if we do a split or do not do a split. Next, let's say now another element comes which is -2 in this case. So what is the best sum we can get if we do a split here? So if we do a split, what we can do? We take this entire thing and we do a split and we say next element is -2. So what do we get? So we get 1 plus -2 which is -1, right? Another possibility is we take this, so whatever we got without the split, and we just do a split here. So that because we have to perform a split here, right, for this value. So we take this number and we perform again a split. So what do we get? 1 plus -2 which is -1. Remember, we have to perform a split here. So we take whatever we have here or whatever we have here and we perform a split and we take this new value. In both the cases we got -1. Next, here we do not do any split. We do not perform any split. So that means I just take this element and I say the next element is -2. Now, since this was a single element and we added one more element, that means the sign has to alternate, right? So it will be 1 minus -2 which is 3, because as we know in the cost of a subarray is nothing but cost of these elements and the signs alternate. Now let's take this one. Again in this case also the sign will change because we do not do any split here. So that means again 1 minus -2 which is 3. Okay, remember this sign changes always. So right now how many elements do we have in our subarray? 2. So for this particular thing we have 2 elements in our subarray. Okay, let's move ahead. Now we get one more index 3. Now let's say what is the maximum sum if we split at index this particular index 2. So this is index 0, this index 1, this index 2. If we split at index 2, what do we get? So we take whatever we have so far, that means we got these values which was 1 or -2, and we do one more split, we take 3. We already do this value is nothing but -1. So -1 plus 3 which is 2. So this is one possibility. Another thing is we take this entire thing and we split and we do 3. So that means we get 1 comma -2. We do a split and we take 3. That means what do we have? We already know the value for this one, which is nothing but 3. So we take 3 plus 3 which is 6. So we take either this one or this one. We do a split and we take this particular array because we have to do a split here. Okay, so dp of I0 is nothing but the maximum, that is maximum of dp of I minus 1 0 plus nums of I, or I minus 1 1 plus nums of I. Why always plus? Because we have done a split here and this is the first element of the subarray. So there will always be the plus sign here. Okay, I hope you are understood so far. Let's see now this one. So we do not do any split here, which means either we take this one, so that means we have 1 minus 2 and we get 3, and we already know this gives us the sum where we have already performed a split. That means it has already one element in the subarray. So what will be the sum? So it will be nothing but -1 plus, so this part is -1 and this will be, because we already know this element is already present in the subarray because there was a split here. So that means it will be minus what is the current element is 3. So that is -4. Why did we do minus? Because we already know there was a split performed here, and so this array has already a split performed and the element is -2 here. So the next element when we include it, we have to do with a minus sign. So minus this particular element is 3, so that is minus 4. So minus 1 minus 3, which is minus 4. Next, we take this entire thing and we do not do any split. So that means we know that there are 2 elements in this subarray. So what will be the next thing? So we have 3. So since we have 2 elements, next element will be what? Plus 3, which is 6. So the best that we can do here as well is 3 plus 3, 6. And how many elements do we have in our count? Count is 3. So if we do not do any split, we can get 6 as the sum, and the count of elements in the subarray will be 3. You can do for yourself as well. Similarly, here what we can get now? So we take either of these and we just include a split and we take this element. So we get either max of, what was the max here? 6. The max here was 6 as well. So which is nothing but 6 plus 4, which is 10. So you can fill this value by yourself as well, and the maximum answer is 10 here. So finalizing, dp of I0 is nothing but maximum of dp of I minus 1 0 plus nums of I, or I minus 1 1 plus nums of I. This is very easy to think. What is dp of I comma 1? So when we do not do any split, so there are 2 cases. Either we take it from here where we already have performed one split, which means we have to take dp of I minus 1 0 minus nums of I, minus because we have already done a split before and we know this is the second element, and that's why this is minus sign. Or we take whatever we have here. So we have to take dp of I minus 1 1 plus nums of I into sign, and we have to compute what is the sign. The sign will be computed by what is the value of the count of subarrays. If the count of subarrays is even, the sign will be positive. If the count of subarrays is odd, then the sign will be minus 1. So that's how we compute the dp. So let's quickly look at the code. So we have this function public long maximum total cost, and it takes the integer array nums. We find the length of the array and store it in the variable n. We take a 2-dimensional dp array which of long, and it has to be n cross 2. Okay. So 0 means we do a split, 1 means we do not do the split. So as I said, the base case is dp of 0 0 is num 0 and 0 1 is also num 0, because whether we do the split or we do not do the split, the first element remains the same. So how many elements we have in our subarray right now is only 1, because we just have nums of 0. So we start with the I equals to 1, we go to the end of the array, and every time we increment I. So I0, dp of I0, if we do the split, is nothing but whatever we had before, we do a split and we take the current element. So it's always I minus 1 0 plus nums of I, or I minus 1 1 plus nums of I, so whichever is maximum. We store in dp of I0. Now comes the interesting part. What is dp of I1? So we discussed we have 2 cases. Either we take it from the split. If we had done a split before and we take it now, what will be? Simply dp of I minus 1 0 minus nums of I, because we have already done a split and we have one element in the previous array and we now include a current element. So the element has to be, there has to be minus sign. Now we compute the sign for case B. So for case B first, how we compute a sign? Sign is nothing but the count of subarrays mod 2. If it is even, then we take it 1 as minus 1. That is the sign. So case B is nothing but I minus 1 1 plus sign cross nums of I. Okay. So if case A is greater than case B, that means dp of I1 has to be case A, and we just have 2 elements, the previous element and the current element nums of I. Else dp of I1 is case B, and the count of elements so far will be just be incremented, because we already had this many elements and we have one more element now. Finally we return maximum of n minus 1 0 or n minus 1 1. Okay. So the time complexity and space complexity for this problem are time complexity is O of n and space is also O of n, because we just iterate through this entire loop and we compute all these constant values. Similarly, we just have one 2D array of size n cross 2, which is nothing but O of n itself. So that's all for this problem. If you learned something today, feel free to like, share and subscribe. Thank you.